Good morning all. This is Satish Kumar, Assistant Professor of EC Department. Now let us see the another video lecture series on standard signals. See, standard signals are represented in both continuous time signals and discrete time signals. Continuous time signal means the variable of time is continuous. A speech signal as a function of time is a continuous time signal. Discrete time signal, the variable of time is discrete. First graphical represents denotes the continuous time signal. Second graphical represents denotes the discrete time signal with respect to amplitude and time. Standard signals are unit step signal, unit impulse signal, unit ramp signal, complex exponential signal, and sinusoidal signal. So unit step signal can be represented by both continuous time and discrete time. U of t is equal to 1 for t greater than or equal to 0, 0 for t less than 0. The graphical representation is given on the right hand side sequence. Discrete time signal u of n is equal to 1 for n greater than or equal to 0, 0 for n less than 0. The graphical representation 0 to up to infinite with respect to n and u of n. It has an amplitude of 1 for all the positive values of independent variables. It has an amplitude of 0 for all the negative values of independent variables. Unit impulse signal del of t is equal to 1 for t is equal to 0, 0 for t should be not equal to 0. The graphical representations can be given. In terms of discrete time signal, del of n is equal to 1 for n is equal to 0, 0 for n should be not equal to 0. The graphical representation 0, the amplitude has 1 with respect to n and del of n. Unit ramp signal is a linearly growing function. R of t is equal to t for t greater than or equal to 0, 0 for t less than 0. It is a linearly growing function. In terms of discrete time signal, R of n is equal to n for n greater than or equal to 0, 0 for n less than 0. In the graphical representation of discrete time ramp signal can be given with respect to n and R of n. Next one, exponential signal. Real exponential signal is defined as x of t is equal to a into e power at, where a is the amplitude. There are three conditions: DC signal, exponentially growing signal, exponential decaying signal. When a is equal to 0 means it has a DC signal. Exponentially growing signal means a greater than 0. When a less than 0 means it is a exponentially decaying signal. The graphical representation of DC signal, exponentially growing signal and exponentially decaying signal can be given here. Next one, complex exponential signal can be defined as x of t is equal to a into e power st, where a is the amplitude, s is the complex variable, s is equal to sigma plus j ohm. Instead of s, we can substitute sigma plus j ohm, which is equal to a into e power sigma t plus e power j ohm t. Therefore, a into e power sigma t is equal to cos ohm t plus j sin ohm t. The graphical representation of imaginary part and real part can be given in terms of continuous time signal and sinusoidal signal in terms of exponentially growing. Real exponential signal is defined as x of n is equal to a power n for n greater than or equal to 0. Therefore, x of n is equal to a power n into e power j omega naught n. Therefore, a power n into cos of omega naught n plus j sin omega naught of n. The decreasing exponential function 0 less than a less than 1. When a is greater than 1 means it has an increasing exponential signal. The imaginary part and real part can be given. Next one, CT sinusoidal signal. Cosinusoidal signal can be defined as x of t is equal to a cos ohm t plus phi. Therefore, phi is equal to 0, x of t is equal to a cos ohm t. The representation can be also be given. Sinusoidal signal is defined as x of t is equal to a sin ohm t plus phi. Phi is equal to 0, x of t is equal to a sin ohm t. The sinusoidal signal can be also be given. Next one, DT sinusoidal signal. Cosinusoidal signal is defined as x of n is equal to a cos omega n. Sinusoidal signal is defined as x of n is equal to a sin omega n. The cosinusoidal signal and sinusoidal signal graphical representation in terms of discrete time can be given. Next one, relationship between unit step and unit ramp. Unit ramp is equal to R of t is equal to t for t greater than or equal to 0, 0 for t less than 0. Unit step, u of t is equal to 1 for t greater than or equal to 0, 0 for t less than 0. Differentiate r of t with respect to t, therefore d by dt into r of t, which is equal to 1 for t greater than or equal to 0, 0 for t less than 0. Therefore d by dt into r of t is equal to u of t. Therefore d into r of t is equal to u of t into dt. Therefore r of t is equal to integral over u of t into dt. Next one, relations between unit step and unit impulse. Unit step is equal to u of t is equal to 1 for t greater than or equal to 0, 0 for t less than 0. Unit impulse del of t is equal to 1 for t equal to 0, 0 for t should be not equal to 0. Differentiate u of t with respect to t, d by dt into u of t is equal to 1 for t is equal to 0, 0 for t should be not equal to 0. Therefore d by dt into u of t is equal to del of t. Therefore d into u of t, which is equal to del of t into dt. Therefore u of t is equal to integral over del of t into dt. Now we can see the assessment. List the classification of standard signals. It is of unit step signal, unit impulse signal, unit ramp signal, complex exponential signal, and sinusoidal signal. What is unit step function? Unit step function can be represented in continuous time as well as in discrete time. U of t is equal to 1 for t greater than or equal to 0, 0 for t less than 0. In terms of discrete time, u of n is equal to 1 for n greater than or equal to 0, 0 for n less than 0. Standard signals is also called as elementary signals. Unit ramp signal, it is a linearly growing function. R of t is equal to t for t greater than or equal to 0, 0 for t less than 0. In terms of discrete time, R of n is equal to n for n greater than or equal to 0, 0 for n less than 0. Unit steps impulse signal is denoted as del of t. Standard signals can be represented in both continuous time and discrete time. The relation between the unit step and unit ramp is given by r of t is equal to integral over u of t into dt. What is mean by sinusoidal signal? Sinusoidal signal can be represented, co-sinusoidal signal can be represented by x of t is equal to a cos of omega naught n. X of n is equal to a sin of omega naught n. Thank you.